and most, building capacity in Africa, and more so in regards to space registration, leadership, and governance. So that's basically what we are doing at ASLI. And our focus right now, or what we would term as the future of what we are doing, is to be, now we are looking at having more collaborations within the sector, so that now we can have a great number of people, experts, who are able to bring in their expertise and help us in building the capacity and strengthening whatever is already existing. So now moving on to the topic of today. Today we are looking at, it's a series on space sustainability, with today's focus being space weather monitoring. I don't know how many of us, other than the facilitators, are acquainted with space weather, and it's a good thing that today you're able to join and get insights on the same, just to understand what is this space weather, how space weather impacts us in our activities, or how can we be able to leverage space weather monitoring for various uses in our sectors. So today we are joined with a speaker, by one of our speaker, who is a doctor in the sector. She has a bachelor's in applied mathematics from the University of Stellenbosch, and then astrophysics from the University of Free State. Again, she was awarded a scholarship and was able to study masters from the Northwest University, just focusing on Earth solar turbulence. And then she earned her PhD in space physics in 2019. And so she is purely equipped for this topic. So you can be sure that you're going to have good substance from her, just to understand what is this space weather and how is it going to benefit us as in the various sectors that we are in. So I would like to invite you, Doctor, just to give your talk and have some good time explaining how space weather monitoring is happening, especially in the scope now learning from SANSA, which has a space weather monitoring station, and what can other African space programs learn from whatever you have done in the sector and be able to move forward. Because remember, many countries are just spacefaring nations, and it will be good and expedient for us to learn from whatever is already happening in SANSA. So you're welcome to share your insights with us. Yes.
Thank you, Esther, for that introduction. And I'm glad you're the monitor for this talk, because I'm looking for a collaborator in Kenya. So we should talk afterwards. Okay, I'm going to share my screen, and please let me know when, or rather if you can't see my presentation.
Yes, yeah, we can see your presentation.
Is that okay?
Yes, you can. Okay. We can see it here. You can go ahead.
Okay, so like Esther said, thank you for that introduction. My name is Amore Nel. I'm the geomagnetic researcher here at SANSA, specifically Hermanus at the Space Science Division. And my journey started years ago with SANSA as a master's student. I got a bursary from them, and there my interest in space physics grew. And I wanted to do my PhD at SANSA, and yeah, for that I looked at auroras, and later on I moved towards geomagnetism. Yes, so you will see where my interest lies in these slides. They will come later. But for this talk today, I'm going to give a broad summary of SANSA's African Instrumentation Network, not only what's already been established, but what we would like to see to be established in the future. And I'll also explain why we want that from a space weather forecasting perspective. So just to start, depending on the audience, I actually forgot to ask Etim who would be attending, but I'll just give a brief introduction of what space weather is, just to get everyone on board. Then I will just give you an idea of what we do here, specifically at SANSA Space Science, which is based in Hermanus, and where the Space Weather Prediction Center is based. Then I will move on to the infrastructure or the instrumentation network that we currently have in Africa. I will look particularly to GNSS receivers as well as magnetometers. Of course, it's impossible in one talk to discuss the whole of the African Instrumentation Network and structure. So my main focus is going to be from SANSA's side. Yes, and then I will just end with the summary and how I see the way forward. Yes, and I do prefer informal talks, so please feel free. I can't see you, I can only see my slide at the moment, but feel free to interrupt me at any point if you want to ask something or give a comment. You're more than welcome. Or if you're more of an introvert, you're welcome to just type the the question in the chat box. I'm sure Esther will monitor that for us. Is there a question? Okay, I'll continue.
Not at the moment.
Okay, good. Okay, so just a brief introduction about SANSA Hermanus. So it's a South African National Space Agency. We have several divisions, of course, across South Africa, but I am based at the Space Science Facility, which was originally established in 1940 in Hermanus. The reason for that is it's actually started as a magnetic observatory, and it was also initially its name. Apologies, my English isn't switching on today. So it was previously known as Hermanus Magnetic Observatory, but it migrated to fall under SANSA in April 2011. So at the moment, we're about 80 employees in this division. And then there's usually about a rotation of 20 people at any point in time, researchers, visiting researchers, students. We are quite active when it comes to hosting workshops and conferences here at Hermanus. It's also a very nice place to visit. People like to come here. We're next to the beautiful beach and everything. We got the international designation as a regional center for space weather information. We operate approximately 40 measuring stations around Southern Africa, as well as at some of our remote sites, which includes Antarctica and some of the islands. And we've also recently been ISO certified. This was necessary to be designated as a regional center for space weather information. So what is space weather? Just a broad definition. It's events from the sun that we experience here on Earth that influences us in some way, specifically the performance and reliability of spaceborne and ground-based technological systems. So basically, space weather is this interaction between the sun and our Earth, and anything that happens there could possibly affect us here on Earth if it's coming from the right direction. It's something that does need to be monitored because it doesn't have an effect on our navigational systems, on communication infrastructure, and we do need to warn our clients if anything is on its way that could affect the technological infrastructure. So at the moment, it's still the only space weather regional warning center in Africa, and it operates as part of the International Space Environment Service, or ISES. And we not only provide information and warnings and alerts about the sun to the public sector, but also the private sector. Also, we fall under the mandate of the AU. They identified space, science, and technology as a key enabler of Africa's agenda for 2063. This is just some of the space weather solutions that we do provide. Yes, I forgot to mention we are a 24/7 operational space weather center now. And like I mentioned earlier, it's information for our clients that could impact navigation and communication applications. We are also very high priority for us is continual research into space weather. We've got a very dynamic space weather research group. We also have our space weather forecasters, and who I believe the majority are busy with their postgraduate degrees at this point. We also continually provide advice and information on how to use the space with the information to mitigate any possible impacts. Just as an example, over the Atlantic Ocean, there's something called the South Atlantic anomaly. Now, what that basically is a region of Earth's magnetic field that is on average 30% weaker than the rest of Earth's magnetic field. So if you see Earth's magnetic field as a protective shield in a way, that protects us partially of solar wind effects, you can see that area over the Atlantic Ocean as a place where a hole is forming in the umbrella that protects us. So it is quite important, especially when there's very active events on the sun, to warn some of our clients so that they can protect their systems like satellites when these events occur. Because over areas like the South Atlantic anomaly, those harmful particles do penetrate deeper and closer to Earth's surface. So that's the type of advice and information we give. And yes, we also provide space weather training for the industry, especially in the aviation sector. Yes, so like I said, one of our mandates fall in very well with the agenda, Africa's agenda that was set out by the African Union, and that is to improve the understanding and awareness of space weather within Africa. Space weather has also been identified as a national risk that could endanger the economy, and this has been established in several countries, including the USA and UK, who have recently listed space weather on the National Risk Register. One of our mandates also is to grow space science in Africa, not just in South Africa. We want to contribute to the growth and development of knowledge within the continent with space weather and space science related research. This could, of course, enable the growing the knowledge economy in the respective partner countries. Yes, the development of an African Instrumentation Network falls under that, because not only will that increase our coverage of space weather over the African sector, it will also contribute to knowledge sharing between African partner institutes. I also added here, because it's impossible to cover everything in one talk, but there's a fantastic paper that was published in 2023 It also includes some of my colleagues here from SANSA. I think one is online too today, Dr. Chillier. And I really highly recommend to go and look for this paper. It's very interesting, and yeah, it's called The Status of Space Weather Infrastructure and Research in Africa. And it goes far beyond just what we do here at SANSA. So yes, go and have a read. We do have so far 80-year history of operating and maintaining instrumentation for the space science community, not just in South Africa, but rather in Southern Africa as well as some of the more remote stations. We have definitely shifted focus now more to establishing an African Instrumentation Network, moving northwards more, and yes, also to provide real-time data to various sectors. Yes, I think I mentioned everything. At the moment, I just need to give a caveat. This is, of course, the establishment of the African Instrumentation Network is not just one individual. It is a massive undertaking that we do as a collective here at SANSA. So I can by no means take credit for this. I will give an overview of the instrumentation network, but please, if there's any more information that you require, or if you would like to come into contact with some of the PIs for these instruments, I'd be more than happy to assist in making that connection. So at the moment, the partners that we do have in Africa is mentioned there. Excuse me. Yeah, and that includes Zimbabwe, Nigeria, Ethiopia. That's where my project is at the moment, which I will mention later in the talk. I am currently in partnership with the Space Science and Geospatial Institute in Addis Ababa, and planning to deploy something at the Intoto Observatory. We also have a domestic partner, TRIGNET, and yes, several universities. There's also in Namibia, in the mining sector. We are planning to expand a bit more in Botswana. Yes, but I will expand on that in the following slides. So yes, more to come. This is just the start for us at the moment. Let's start with GNSS data, or the GNSS receiver network. So there is a great appetite for it. Just to give an overview. So GNSS is a global navigation satellite system. And yeah, it's basically that's used for positioning, navigation, and timing. It also gives us information about our ionosphere. And again, this is not my research topic, so I will just mention it briefly, but I'll be more than happy to, if anyone is interested in more information, to guide you to the relevant experts at SANSA that can tell you more, especially Dr. Matamba. Yeah. But yes, we are interested from a space weather prediction point of view. We're interested in the GNSS network because it tells us what's happening in the ionosphere and how those disturbances caused by solar or sun weather, how that can affect the quality of these GNSS frequencies and degrade the signal. This is, of course, very important to us because we use it for positioning, and we need to know basically what the ranging error can be at any point in time. So there you can see a practical application of space weather forecasting. Then we've also introduced SBAS. from what I understand, we did a proof of concept in South Africa for ISES. It's a satellite-based augmentation service, basically a method to improve the GPS signal. We did a proof of concept here in South Africa, but it is not operational at the moment. But from what I understand from our managing director, the results were successful. Can I go forward? Yes, and as you can see, there is a gap in the African sector which we would like to fill in the future, but due to the geographical size, at least 4 ISPAS services would be needed to cover the whole of Africa. And also to keeping in mind that there's a lot of ionospheric activity, interesting things for researchers happening along the equator, plus minus 10 to 15 degrees. So yes, those are the 2 things that we have to take into account when considering how many ISPAS modules would need to be incorporated. Yes, ISPAS has not yet been fully deployed in all the regions, likely due to cost constraints. And yes, like I mentioned earlier, yes, there was a proof of concept here in South Africa for Module 4, which was successful. And yes, here is some of the applications for ISPAS. Yeah, you can imagine anything that you need accurate positioning for navigation, it would be applicable there. Yes, then we also have a course network. So TrickNet is a network of continuously operating GNSS base stations, and they cover South Africa. Yes, as you can see there, and yeah, managed and controlled by a single control center, and they are based at the offices of the National Geospatial Information Center. So the development of GNSS, especially of GPS, has led to the operation of continuous operating reference stations. That's what CORS stand for. And they acquire GPS signals without any interruption. And these stations have been set up to permanently track GNSS signals continuously. So just briefly, the planned installations. There's one scintillation GNSS receiver planned for Uganda. And yes, the main question always is, of course, we want to look for partners in other African countries that are also interested in the output and is willing to provide the infrastructure and technical capability that is needed to establish, any type of instrumentation. Yes, there's Botswana. Here we are also considering, yes, there you can see the blue triangle. We are considering establishing a geomagnetic station there. We currently have 4 intermagnet observatories in Southern Africa, which is maintained by SANSA. And these are magnetic stations that need to adhere to an international standard. And it does require quite a lot of legwork to establish an intermagnet station, but that is the final aim, to eventually establish an intermagnet station there. And yes, some of our researchers, especially Dr. Nahayu, have been there scouting for new sites, to basically explore new geomagnetic station sites. Then it's Namibia. There's 2 core stations for ISPAS. Other things that I'm not familiar with, but I definitely have colleagues that can give you, help you with the technical information. What's not shown here is we also have 2 intermagnet stations here, one at Sumek and one at Keetmanshoop. And then, of course, Zambia, which I mentioned, Zimbabwe. Just keep in mind that some of these are still planned deployments, but talks are underway. Yes, Nigeria, Kenya. Okay, Ethiopia, of course, I'm especially interested in Ethiopian partnerships, and I will come to those slides later. And here's just a full station list. We have a very nice interactive map that shows a list of instrumentation, active instruments where we are receiving data. So if there's any queries, please do not hesitate to contact me, and I will get you in contact with our data management team. Yes, if you're interested in any of the data instrument information. Now, coming to my pet project, is I am, like I mentioned, geomagnetic researcher, and I am interested in the magnetic equator because a lot of interesting sciencey stuff happens there. Now, the magnetic equator isn't where the geographic equator is. You can see here on the map that was sponsored by one of our research partners in Germany, the GFZ. And yes, unfortunately, at the moment, we do have a very sparse coverage of magnetometer stations along the magnetic equator, which is a pity because, for example, one of the ionospheric events that we would like to study there is the equatorial electrojet. And for that, we need more magnetic stations. Here's some examples of research topics that can be looked at, and also explaining the reason why we need certain type of magnetic instrumentation. And also very important, we need 2 stations, one on the magnetic equator within 3 degrees in that band, and then one further away. Here you can see Yamazaki et al. 2017 suggested 6 to 9 degrees further away from the magnetic equator latitudinally. It's only with a combination of these 2 stations that you would be able to measure that equatorial enhancement. Yes, which occurs in the ionosphere. I started an investigation about 3 years ago, to enable me to apply for a grant for this endeavor. And I had to first look what active magnetometer sites there are in that area. There has been stations deployed there, but unfortunately a lot of them have been decommissioned due to several reasons. I know the one that was based in Addis Ababa is now, due to disturbances in and around Addis Ababa, it is can't be used anymore at this point. Excuse me. Yes, there are several intermagnet observatories, as well as MAGDAS sites and AMBER instruments, but due to inactivity or just not at the correct location for the studies we're interested in when it comes to space weather, just currently no good, yes, magnetometer stations that can be used for these studies in the magnetic equatorial region. And that is why we proposed to deploy magnetometer stations. And the first one is going to be now in partnership with the Space Science and Geospatial Institute in Ethiopia. I'm just going to skip this. This is not that important. Yeah, we're going to deploy it in partnership with the Space Science and Geospatial Institute in Ethiopia in this year, which I'm looking forward to. It's been a 3-year journey. This is one of the proposed protective structures that we suggested for this project. This is also the typical structure we use when we deploy in and around Southern Africa. There was unfortunately a budget constraint due to the size of my grant. So it gave us an opportunity to design a completely new one, loosely based on the one based in Namibia in Keetmanshoop, but with some slight adjustments. For example, it doesn't flood in Keetmanshoop, so obviously we couldn't design a station that is underground. That would not be good. So we've made some adjustments. And our aim for this design was to create something where the building materials are readily available. No, it doesn't matter where you are in a remote area. There's nothing funny about the building materials that you would need. For example, this fiberglass dome, you need a mold, and the mold is in South Africa. So you'll have to ship this massive structure to wherever you want to deploy it. It was just financially not possible. It's a bit unrealistic. So we opted for a new design, and basically all the building supplies are affordable and can be readily found anywhere. So yes, that is what we're going to deploy later this year. This is just an example of another magnetometer station that we've deployed in South Africa. And that was with the help of our senior technician, Ziad ISES. He's also my collaborator for this project that we're going to have in Ethiopia. And yes, we learned a lot from this project. For example, although this area in South Africa looks very dry, I think about a month after we deployed it, there was a flood. So what you see here now, a month later, it looked like there was a river, and everything was still fine after the flood. So we now know that the design used for this magnetometer station is robust enough for any type of weather. One thing that is also part of our mandate when it comes to deploying in remote areas is visibility. We don't want it to stick out like an eyesore. We also want it to be completely independent of the surrounding infrastructure. And that includes the data transfer, the energy source and everything. So all of this needs to be tested before it is deployed. Like I mentioned earlier, we have a partner in Ethiopia. It's my main collaborator there is Dr. Ngusi Gidey. We both worked on our PhDs together here at Hermanus. So we've come a long way together, and he's now based at the Space Science and Geospatial Institute in Addis Ababa, and we will go and visit him later this year for our deployment. In the beginning, we obviously, in Toto Observatory is ideal for what we want to do. It's just outside Addis Ababa. It's in a empty field. I think it's north of the observatory. There's a forest, so it's nice and remote. There's no disturbances or areas where there can be any infrastructure established later. So it's the ideal spot for us. And we also wanted to deploy our second station at the University of Adrigat. That plan has been paused at this point, and we are considering now rather to deploy the second station in Kenya. But that would be phase 2, and after this first deployment, we'll look at, yes, that second station. And this is just a typical, example of when we do want to establish a magnetic station, what we do need from our partner host institute. We do mention a power supply and so on, but like I said, we have adapted our plan so that it's actually not even necessary. But it's always good to have a backup. And my dream, of course, is to one day, have an east-west chain of magnetometer site pairs across the equatorial region. That is the dream. So I'm always looking for, funding, but that will come with time, and also partners in the respective African countries where we would like to deploy it, institutions that would be willing to host it for us. And for me, it's very important, and we've already started doing this with the SSGI, is not only them visiting us, but we and our students to go and visit them, and work on projects together, collect and process data together, train the technicians together, and also publish the work together as the respective African institutes. That is the aim, and so far it's going well. Yes, well, I don't have to, I basically already mentioned this, so we can stop that. So just in summary, we are host to the only space with a regional warning center in Africa, and it operates as part of the International Space Environment Service. Because of this service and the monitoring of the sun, we always aim to increase the precision that we can forecast space weather and send warnings and alerts to our clients. And for that, we need to continue our research. We need to continue to establish instrumentation that provides us with valuable data that helps us to better our models that we use for these predictions. And we are always looking for partnerships in the African sector, not only for deploying stations, but also to share knowledge with and do cross-training and so on. Yes, I think I mentioned everything. Yes. We want to have a flow of real-time data to this new space weather center, hence the need for the expansion of the instrumentation network. We also want to fill some of the, make the network, instrumentation network, a bit more dense. That will always be good. And yes, that's it. Thank you so much.
All right, thank you so much, Dr. Amor.
I hope I didn't go over time. Sorry.
No, it's okay. You're quite on time.
Okay,
That was yes, that was just on point. So we have several questions that are coming in from different people, and maybe we can start with the basic one. Is there any connection between space weather and climate, or can we use space weather to monitor maybe climate change and the effects thereof?
Yes, that's a tricky one to answer. There hasn't been a direct correlation, But that being said, there has been studies to see whether there is a connection. I'm just trying to remember the paper that referred to the increase in dust particles and height, but I will have to get back to you. Let me just make a note of that. I would very much would like to refer whoever asked that question to the paper I'm referring to. But in general, there isn't a direct correlation, no.
Okay. Thank you. So I'm reading from the charts. Somebody asked what kind of instruments are outside South Africa. I think you kind of mentioned it, but maybe you can clarify in regards to GNSS or just magnetometers.
Let me, to answer that question, let me open, oh, I'm so glad I have it in my bookmarks. Yes, our communications officer made a fantastic active map, and I was able to open it. So let me share my screen, which would answer that question. Okay, can you see Africa?
So we can see.
Okay, good. So here you can see, and I would be happy. I'll be happy to share this. I don't think this is an internal link. I think it should work for everyone. Yes, I'm pretty sure it'll work for everyone. And this gives a nice summary of the instrumentation network we have currently. So it doesn't take into account all our planned deployments. So when you ask for outside of South Africa, yes, here's the GNSS receiver at Tsumeb, and then there will be one at well, this is the Intermagnet Observatory at Keetmanshoop, but there are a GNSS receiver and an Intermagnet Observatory at both these locations. And then Zambia, here's the GNSS receiver. One in, I'm embarrassed now, I don't know how to pronounce Shavuma. Yes. Here's the one in Kilifi. And then also our remote stations is here on Gough Island. You can see WSPR beacon and GNSS receiver. And on Marion Island, we have a VLF receiver and a GNSS receiver site. And I'm pretty sure we're planning to deploy a magnetometer station there too, but I'll have to check with my colleagues. Okay, we definitely have magnetometer stations in Antarctica, at our Sunray base here. Yeah. So let me put this link in the chat, and you're more than welcome to go and have a look.
That is well noted. So another question somebody asked about whether there are specific satellites that monitor space weather. I think it's because of the connection with the South Africa Space Agency. So maybe you can clarify whether there are specific satellites that monitor space weather applications.
Okay, so I'm going to ask you to repeat that because Esther, I'm a 40-year-old lady and I didn't know how to put this link in the chat, so you'll have to help me, please. I will email the link to maybe to Jette. Okay, good. Sorry.
Okay.
Please repeat that question. Sorry about that.
Okay, no, that's okay. That will work. So somebody was asking about specific satellites that can monitor space weather. I said maybe it's because of the connection with the South Africa Space Agency, because most of the people, when they hear about a space agency, what relates to them more is on the satellite. Maybe you can clarify whether there are specific satellites that monitor space weather.
Specific what? Instruments?
Satellites.
Oh, satellites. Yes,
Yeah.
no, several, sorry. There's several satellites that monitor space weather, and depending on what payload they have, or the instruments that they have on board, will depend what you can measure about space weather. So it can be anything from solar wind speed. I wonder, wait, I'm going to share something again because it's always nice to have a visual. Okay. Share screen. No, not this one. Sorry. Okay. So here it is. So, oops, no, not this one. So, no, there's a lot of satellites, and like I said, depending on the instrumentation it has on board, that tells us more about space weather. And we are also very interested in not only what happens close to us here on Earth, but also things that are happening on the sun, close to the sun, because that's going to increase our understanding of these physical phenomena. And that would automatically increase our prediction capabilities when it comes to space weather. So the answer is many satellites. It depends on what you're interested in. I'm, for example, interested in magnetic information, magnetic data, because I want to know how Earth's magnetic field reacts when there's a huge sunstorm that hits us, for example. Yes. Okay, does that answer it, Esther?
Yes, it does. So somebody else is asking whether you sort of partner or collaborate with private sector, say somebody who is a provider of GNSS services within the African spectrum.
I wonder if Dr. Sillier is still online, because that's not my field of expertise. I'm not part of those discussions for the GNSS, but I can definitely, it doesn't sound like Dr. Sillier is here. Let me write that question down. I can find the answer for you. If the person would like a follow-up answer to that.
Yeah,
Yes,
all right.
I can offer an answer there. If,
Thank you, Doctor.
Yeah. You're most welcome.
We are collaborating with several countries in Africa on research in using GNSS for various applications, particularly with Ethiopia, Kenya, Nigeria, Uganda, to name a few. Where we are collaborating on research papers and also on sharing data.
All right, thank you.
I also have an answer to the previous question regarding the link between space weather and terrestrial weather. Amore mentioned that there was once a theory that the particles that enter our atmosphere from cosmic radiation serve as condensation centers for rain to form, and that may still be a mechanism for which space events may affect terrestrial weather, such as rain and storms. But the more recent thinking is that it is not so much cosmic radiation as the changes in the composition of our upper atmosphere due to the ionization by high energy particles from the sun. And so if there's an increase in the nitrous oxides and they change the composition of the atmosphere, thereby change local pressures and densities, and that gives rise to winds and storms as we may know it. But that's an ongoing research field because there's clear evidence from history that there has been some instances of big impact on the terrestrial weather, but notably so during the so-called Maunder minimum, a period of several tens of years that there was very, very cold temperatures all over the Earth. It was called the Small Ice Age. And that happened during a period when there were no sunspots. And typically the sunspots are an indication of space weather activity centers on the sun. And most of our major storms from the sun come from regions which we identify as sunspots.
All right, thank you for your contribution. So I forgot to mention we have also other experts in space weather, GNSS, who have joined from SANSA. So he's one of them who has answered that question. So also to the students who are joining us for this webinar, you see there are platforms and opportunities for you to research in space weather, for example, in that area of how space weather maybe relates to the normal climate and weather aspect in that directly affects us. So it's also an opportunity for you to see whether you can plug in and contribute to the wealth of knowledge in the space weather sector. So moving on to another question, there's somebody who is asking, how do you foresee the contribution of Regional Space Weather Center that you're hosting at SANSA in the development of SBAS in Africa?
That's definitely something I'll have to refer to one of my colleagues. I'm not involved in those talks, but if you can give me the name of the person who asked the question, I can get them an answer after the webinar. And it would probably be our managing director at the moment that will have to answer that, yeah, because he's part of those discussions.
Okay. Maybe again in regards to the work that you're currently doing, you can maybe mention about your contributions to ICAO.
Okay. What we plan to, how we're currently collaborating with them. Okay. Yeah, that's Dr. Rindani that works with that partnership. I can just give a very broad overview, and that is the fact that space weather has been identified as a risk to our economic infrastructure. It has become one of their mandates to provide the aviation industry with space weather forecasting information. So that's just a broad overview. There's much more detail and discussions and working papers. It also involves the training of those in the aviation sectors, for example, in the background knowledge of space weather, so that they know when they do receive these alerts, what exactly does it mean. So yeah, it's providing information and it's training, to summarize.
Okay, maybe you can also mention what is the future of space weather in regards to Africa? What are some of the ways that Africa can, as a continent, so to speak, through the various space programs, what are some of the things that we can do to make sure that we are benefiting or we are part of space weather monitoring? Yeah.
I mean, space weather monitoring and establishing a space industry, it roughly has the same answer, and that is for us to compete on an international platform, we do need to work together. We do need to partner up. I highly suggest an African space weather center. It's extremely important to share knowledge and do collaborations and partner up. because it's not going to go away as our technology becomes more and more dependent on space weather, with the increase in satellites and so on, which affects our navigational and communication capabilities. The forecasting of space weather just becomes more and more important. And we do want to be part of those discussions, and we do want to be how can I say, not one of the stakeholders, but one of the active members in the global space weather community. And I think for that to happen, we do need to establish an African partnership. Yeah. And that just starts with baby steps. For example, hosting instrumentation together, sharing knowledge between institutes, not working individually, but rather as a collective. I know that's a very vague answer, but I hope it makes sense.
Yeah, it does. And another question, you mentioned that there are instruments that you have sort of installed in different African countries.
Mhm.
So, for example, if as Kenya we have a magnetometer that we have installed, but it's up
Mm.
to standards, are you able to make use of that data, and what would that mechanism of working together look like in
You
a
would
brief?
make my day if you told me you had magnetic data for me. We need to talk afterwards. No, basically, there is specifically when it comes to magnetic data, there is a international standard that we adhere to. It's called IAGA. And first of all, we will measure the data for its quality, basically. It also depends what type of magnetic information is it. Is it a total field measurement, or is it all three components? Yeah, what type of magnetic data do we receive? Yeah. And then when it comes to basically signing a memorandum of agreement or that type of thing, that's another division in SANSA. But our mandate is free data for research purposes. I also plan to do that with my deployment in Ethiopia later this year. The data is going to be free for anyone that wants to use it for research purposes or for science. Yes. So that if we ever sign something, it won't be for it'll be free, the data for research.
Okay. Maybe from the floor, I can ask if there's anybody else with a question. But in the meantime, you mentioned about working with the African continent holistically, and now with the establishment of the African Space Agency, is it something that you are considering in regards to now approaching them in terms of collaboration, because they are sort of a centralized body for the Africa space sector players, or is it something of consideration from your end?
Oh, absolutely. But these discussions have been going on for quite a while, for a few years. I forgot now which conference it was. I think 10 years ago. We had a space policy roundtable end of last year where we continued those discussions, and I think we all agree. It's just we all agree that we need to work together and we need to be part of this. It's the space industry, that was the topic, but space weather forecasting also falls under this. But we do need to just take that first step and decide what that step is going to be to get there. So I think when it comes to the ideology, we all agree, we all want the same thing. It's just figuring out the logistics. of how to get there. Yeah.
Yeah,
Yeah.
yeah. All right, so maybe you can share your email with the team or with the participants.
Absolutely.
Yeah, so that, for example, those who have follow-up questions can be able to get in touch with you.
I don't
And
know when I got so bad with technology, I keep messaging Joseph and he's left. So I need to meet in group chat. Oh, no, at g.org.za. If anyone didn't see the email, my email address, please just ask,
yeah, we can see it.
the
Thank you.
organizers to, okay, good.
Yeah, thank you. So once again, thank you for joining us today and sharing your insights on space weather monitoring. I'm sure because you said it's a broad topic, and this is just sort of laying grounds on having an introduction of the same. We are hopeful to have such interactions in the future where we can explore more and get to understand how, as the body of researchers, how can we plug in and contribute to the same. So thank you so much for joining us today.
And I want to thank your institute for creating these discussions because these conversations, it needs to happen and has to continue. Yeah, so thank you for that.
Yeah, maybe you can give your closing remarks on the same again. Maybe highlights of what you would want to tell us, and maybe you could comment also on the aurora for phenomenon that they said is happening on the southern hemisphere. Say, is it 20th and 21st? They said we should watch out for something amazing in the skies. Maybe you can comment on that on your
That would
closing
have
remarks.
to be a massive massive storm if we would be able to see it in South Africa. What did they say? The last time we saw auroras in South Africa, and that was before my time, well, I couldn't remember. What was it? 1989, I think. Yeah. Okay, that must be a massive storm. I'll have to go and look up. Yes, Pierre.
It was in 2003 during the Halloween storm that the aurora was seen from a ship off the South African coast.
But also in Durban, I think that was the storm in 1989. Yeah.
I'm not aware of that one. That may be another occasion, yes.
Yeah. Yeah. Yeah, but to summarize, Esther, like you asked, it's just SANSA's open to partnerships in Africa to host instrumentation as well as to deploy together, instruments together. And yeah, feel free to contact us and I will introduce you to the right people to talk to if anyone is interested. Yeah, thank you.
All right, thank you too. Thank you also to the experts who have joined us from various parts of the continent and the world. We are happy to have you in this conversation so that we can grow together in the journey of space sector. So to the participant, we look forward to having you in our next webinar. And thank you for joining us. Just to mention, if you're interested in learning about space weather, you can get in touch with our speaker today. If you want to learn more about what ASLI is doing, you can also visit our website and the socials where we share more information and also invitations for such webinars and roundtable communications and talks. So you're free to visit our website and get to know more about us. So wishing you wonderful evening or morning or afternoon or night, depending on what part of the world you are in, and looking forward to having you some other time. So bye everyone. That's
Bye, Steve.
sorry.
Bye.
Is that a hand raised or a bye? That we
Bye
don't
bye.
close. Okay, so bye
Bye,
everyone.
Esther. Bye, everyone.
Okay, bye.